Okay, we're going to do 8.2, integration by parts. Sorry, I didn't realize I hadn't fixed that. Consider the product rule for the function u times v. So if we take the derivative and we do the chain rule, so we'll get u v prime plus v u prime. Then if we integrate u times v, right, we take the integral of u dv plus the integral of v dv. And rewriting this, we have the theorem 8.1. So 8.1 is integration by parts. If u and v are functions of x with continuous derivatives, then we have the integral of u dv to equal u times v minus the integral of v du. So some guidelines for choosing u and dv. So if we let dv be the most complicated part that fits the integrand of the basic integration rules, and then let u be the function that will become simpler as derivatives are taken. Okay. All right, so we do this first part, and we need to figure out what is u going to be, and then when we figure out that, we do the derivative du, and then we need to figure out what v is and the derivative dv. Okay, so let's pick u first, okay? So I want it to be the simpler derivative, okay? And we have x cubed and natural log of x, okay? So the natural log of x would actually be the easier form to do the derivative. And if you remember, the derivative is going to be 1 over x dx, okay? And you're kind of working diagonally. So this is what we need to find first, okay? So if we're saying that ln of x is going to be u, then dv is going to be x cubed. Okay? And then how do we get, I'm sorry, I forgot dx. How do we get the integral, or what is the integral of x cubed? So then that would be 1/4 x to the 4th. Okay? And at this moment right now, we're not going to, sorry, I was looking at something. We're not going to I don't know what I was going to say. Oh, we're not going to put the plus c. Sorry, that's what I was going to say. On v, because we're going to do that at the end when we actually finish the chain rule, integration by parts, so that we have the plus c there. Okay? So the beginning says u times v. So u times v will actually be going this way first, okay? So u times v would be 1/4 x to the 4th ln of x. I just like writing ln of x at the end. That's the only reason why I put it at the end, okay? And then we're going to do minus, and then we're actually going to do the multiplication of this second diagonal, okay? So I'm going to just, I'm just going to write everything multiplication, okay? So it's v times dv. So 1/4 x to the 4th times 1 over x dx, okay? So let's clean up that integral before we actually take the integral. So then this would give us still this x, 1/4 x to the 4th ln of x, and then minus, let's take out the 1/4 to the integral, and then if you notice, this simplifies to just be x cubed dx. Okay, so now let's do the integral. So we have 1/4 x to the 4th ln of x minus 1/4 times, what is the integral of x cubed? Well, 1/4 x to the 4th, and then plus c. Okay, and this is where the c comes into play, which is why you don't need it up here for the v, okay? So then this equals 1/4 x to the 4th ln of x minus 1/16 x to the 4th plus c. And we're done. Okay, so the hardest part here is figuring out what is u and what is dv. Okay, once you figure that out, then everything else, I mean, should be pretty simple with not doing anything we haven't done before, anything crazy. Okay, so let's do the next example. So the next example again, what is u, what is du, what is v, and what is dv. Okay, so remember, we want to, whatever's easiest to take an integral, whatever's easier to take a derivative, that's going to determine who's u and who's dv. Okay, so here I would actually put x cubed here, and only because if we take the integral for e to the x, it's just e to the x. Okay, so that makes it a little bit easier in that sense. Okay, taking the derivative of x cubed is a lot easier. So that's why I'm making x cubed now this time here. So the derivative of x cubed is 3x squared dx. Okay, so if we write this, actually let me put it down here. If we write this out, so it's u times v, so x cubed e to the x, or e to the x cubed, either way would be fine, minus the integral, and then I have 3x squared e to the x dx. Okay, I'm gonna leave it like that, and this is actually, again, this would be another integration by parts. So again, what is u, du, what is v, what is dv? So we start with u and dv. So again, e to the x dx is going to be my dv. So that means 3x squared is going to be my u. Derivative of that would give me 6x dx. And then the integral of e to the x is just e to the x. Okay, so I write it again. So equals x cubed e to the x minus, and I'm going to put this in brackets because I don't want to lose a minus, okay? So I then get 3x squared e to the x minus the integral of 6x e to the x dx. So that's pretty much, again, let me just distribute that negative. So I get x cubed e to the x minus 3x squared e to the x plus the integral of 6x e to the x dx. And I have to do it again. Okay, so then I have u equals du equals v equals dv equals, okay, so again, e to the x dx, and this is going to be e to the x. U is going to be 6x, and the derivative is 6 dx. Okay, so then I have x cubed e to the x minus 3x squared e to the x plus, and if you want to put the brackets, we can put the brackets. This would be 6x times e to the x minus the integral of 6 e to the x dx. Okay, so now I can take the integral. These brackets are really unnecessary. So x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus, well, I can take out the 6, right? And then what's the integral of e to the x? Well, e to the x plus c. And that's my final answer. Okay, so if you see that if you do it by parts, it's really going to take you nowhere, right? If we had it from the beginning set up, if we had set up this part here, right, with you just only use substitution, it would have not taken us anywhere, right? It wouldn't have eliminated anything. You wouldn't have been able to really do much. So this is why we had to integrate by parts again, a third time, okay? All right, so here we have e to the 2x sine x. So again, what is u? Du. What is v? dv. Okay, so here we have e to the 2x, the integral of e to the 2x sine x dx. Okay, so figuring out what is u and what is dv. So here the easiest part to do the integral would be sine x dx. E to the 2x, the reason why I chose that, now I chose it only because it has the 2x, okay? If I had e to the x sine 2x, I would have chosen sine 2x to be my u, okay? So that's the real reason why I chose that, okay? And besides the fact sine will always flip-flop between cosine and sine and cosine, negative cosine and sine. So that one's easy to integrate as well, okay? But if it had sine 2x, then I would have chose that to be u. Okay, I'm only choosing e to the 2x because of the 2x to be u, okay? So then the the derivative of e to the 2x would give me 2 e to the 2x dx, okay? And then the integral of sine x dx would give me negative cosine x, okay? And if you don't remember, that's okay. We have that worksheet that I told you guys yesterday. Use it, right? Use it, okay? So this would give us negative e to the 2x cosine x minus the integral of negative 2 e to the 2x cosine x dx. Okay, so let's clean this up a little bit. Let's leave the 2 inside because we're gonna have to take again the integration by parts. So negative e to the 2x cosine x plus, and then we have the integral of 2 e to the 2x cosine x dx. So again, what is u? What is v? Okay, so u, again, is going to be the e to the 2x, so 2 e to the 2x. The derivative of that would be 4 e to the 2x dx. And then my dv is going to be cosine x. So cosine x dx, the integral of that is going to be sine x. Okay, so negative e to the 2x cosine x plus 2 e to the 2x sine x minus the integral of 4 e to the 2x sine x dx. Okay, so now here, there's something special here. Okay, if I take out this 4, let me highlight it. if I take out this 4, what is left over is actually what I have from the beginning. So then, in reality, let me see if I can make it fit here. This equals the integral of e to the 2x sine x dx. So that is going here. Okay. Why am I going to do that? Well, if I rewrite it, e to the 2x sine x dx equals negative e to the 2x cosine x plus 2 e to the 2x sine x minus 4 integral of e to the 2x sine x dx. Then I'm gonna do this as algebra. Okay, I'm gonna pretend that what it's equal to, that's like an x value. I'm gonna use it as a variable. So I'm gonna add for the integral of e to the 2x sine x dx for the integral e to the 2x sine x dx. So why am I going to do that? So that gives me 5. The integral of e to the 2x sine x dx equals negative e to the 2x cosine x plus 2 e to the 2x sine x. And then what I'm going to do is I'm going to divide every term by 5. And that's going to give me my equals value on the right hand side. I mean the left hand side, sorry. So I get negative 1/5. Shh, be quiet. E to the 2x cosine x plus 2/5 e to the 2x sine x. And that'll be my final answer. Oh, I forgot something. Plus c. Plus c. That's my final answer. Okay, so just kind of manipulating it a little so that I'm not just going in circles, because if I keep doing partials, it's just going to continue going in circles, and it's not going to be helpful. Sorry, close the door. Hopefully, I mean, they're still going to bark, but hopefully it won't be that bad. I promise my dog is not dying. She cries like a crazy maniac. All right. So D, I have the integral of x, square root of x minus 5 dx. So for this one, we actually, if you look at it, I can just do u substitution. I don't have to do integration by parts. So be careful, and unless it's, complicated, do not. Well, for this one, I do not need integration by parts. Okay, I can just do substitution. Okay, so I'm going to just do u substitution. So u is actually going to equal what's inside of the radical, so x minus 5. And then du will just equal dx. Okay, well, you're probably saying, well, that's not helpful for my x in front of that radical. But again, let's manipulate things. If I rewrite this and solve it for x, this would give me u plus 5 will equal x. So this is what I'm going to substitute for x, and this is what I'm going to substitute for u. Okay, so let's rewrite it. So the integral of u plus 5, and then times the square root of u du. Now here, I can do the distributive property with this and distribute to everybody inside the parentheses. The other way, I cannot take it out of the radical, right? And the x cannot go inside the radical. So this is a little bit of way of manipulating this. Okay, so I'm going to rewrite square root of u to equal u to the 1/2. So then this will give me the integral of u times u to the 1/2 plus 5u to the 1/2 du. Okay, so let's just do some cleanup. So what is u times u to the 1/2? Remember, this is 1 and they add up. So this is really u to the 3/2 plus 5u to the 1/2 du. And this is a lot easier to take the integral for, correct? So this would give me 2/5 u to the 5/2 plus 5 times 2/3 u to the 3/2 plus c. Okay, so let's substitute back our u. So this is going to be 2/5. And I'm going to rewrite it as a radical again of x minus 5 quantity to the 5th power plus 10 over 3, the square root of x minus 5 quantity cubed plus c. Now, I'm fine with this being your answer. If you, on WebAssign, it might ask you to simplify the radicals, meaning that this is, right, so I have 5 of them, so 2 can get out. So I have 2/5 times x minus 5 quantity square root of x minus 5 inside, plus 10 over 3 times x minus 5. Let me fix that 5. Square root of x minus 5 plus c. So either one is fine. I'd prefer the top one over the bottom one, but just because I don't want you to do so much work. Okay. If I would try this first one on WebAssign, if it doesn't accept it, then take out the radicals. Okay. Or simplify the radicals, I should say. Okay, so here I have find the definite integral. So I do have integration. I'm going to do integration by parts. Okay, so I have u equals, du equals, v equals, and dv equals. Okay, you're probably telling me, well, there's only one part to it, right? There's only the natural log of 4 plus x squared. Okay, so that would become easier once you take the derivative. So that would be 1 over 4 plus x squared times 2x dx. And our dv part is going to just be dx. Okay, so our integral for dx is just x. Okay, purposely I'm doing it this way so that it can actually simplify a lot better. You can't do, if you were to do just a u substitution, you really don't have an x to get rid of, so that's why you can't do it by u substitution, right? So if you were just to say that u equals 4 plus x squared, then the issue would be here, getting 2x dx. Okay, you don't have anywhere for that x to substitute. So this is why just u substitution will not be okay. Okay? All right, so we get x times ln of 4 plus x squared minus the integral of 1 over 4 plus x squared times 2x times x dx. Okay. If you want to leave out the integral for right now, just for right now, and then we'll Well, make sure to take it at the end. That's fine with me because you're doing a lot of steps anyways, okay? So I'm just going to leave it without for right now, but I will make sure to go from 0 to 1 once we get to the end. So I have x ln 4 plus x squared minus, so let's clean this integral up before I do it. So it's going to be 2x squared over 4 plus x squared dx. Okay, and again, if you do the u substitution, it's not going to get rid of the x in the numerator, so this is going to be hard to integrate, okay? So what I need to pull out of my hat, remember I told you guys there's a lot of stuff you're going to have to pull out of your hat for these. I'm going to do long division. Who remembers long division? So, let me see, where do I have a little bit of room? Maybe here? Let's do some long division. Okay, so inside of the house, the division house is 2x squared. Outside, I'm going to rewrite it correctly. So x squared plus 4, just so I can do the long division. I'm just rewriting it mathematically correct. Okay, so remember how many times, what do I need to multiply 2x, what do I need to multiply x squared to get 2x squared? So that's a 2. And then down here I write minus 2x squared minus 8. Okay, so that goes away, which is perfect. And I have a remainder of negative 8. Okay, so let me rewrite this to equal x natural log of 4 plus x squared minus the integral. And then this gave me 2 minus 8 over 4 plus x squared dx. Okay, well, I can do the integral for 2. That's pretty easy. Now here, for this part of it, if you remember, this is going to be arctangent. Okay, where u is equal to x and a is equal to 2, because this is a squared plus x, u squared, sorry. Okay, that rewrote. Okay, and then highlight it again. Okay, so x ln of 4 plus x squared minus, and I'll put this portion in parentheses, okay? In brackets, I should say. So the integral of 2 is 2x minus, I'm going to write this 8, I'm going to write it in the front, and then times, so this becomes 1/2, 1 over a, arctangent of, and then it's u over a, so x over 2. Okay? So let me clean this up, and then we can evaluate it from 0 to 1. So then I have, and I'll put it all in parentheses, or brackets, x ln of 4 plus x squared minus 2x plus, what, 1/2 times 8 is really 4, arctangent x over 2, close it, and then it's evaluated from 0 to 1. So let's evaluate it. So 1 times the natural log of 4 plus 1 squared minus 2 times 1 plus 4 times the arctangent of 1/2, and then minus, so that's that part, minus, and then it's going to be 0, because 0 times anything, minus 0 again, and then plus 4 arctangent of 0. Okay. So in reality, this also arctangent of 0 is 0, so it goes to 0. So really the whole 0 part goes away. So let's work with what I have on the left-hand side. So this becomes natural log of 5 minus 2 plus 4 arctangent of 1/2. And that's it, guys. That's 8.2. So there's a lot of stuff you got to pull out of the hat for this section, okay? So think algebra, think geometry, think trig, think every which way you can so that you're able to do all this, okay? And especially all the integrations, right? Arctangent, any kind of trig functions that we have for integration, for derivatives. Okay, so make sure that sheet is out and you're using